let's talk about Venn diagrams. You've all seen these before, and if this is something that you kind of want to sketch out as we talk about it, want to sketch it out on your green formula sheet to use on the test, feel free to do that. So you are going to see Venn diagrams, which is one or typically more, which is most of the time it's two. You can have a Venn diagram with 3 circles, but most of the time it's 2, surrounded by a rectangle. The rectangle may not seem important, but it's going to hold numbers that are in neither of these events, either of these sets. So the rectangle is important to draw so that you can label the number that's outside of the sets. So let's look at this example. We are going to take this two-way table and we're going to organize this data into a Venn diagram. In a previous example, we looked at data from a class activity. Okay, I'm not going to read all of that, but basically here's the taco tongue and evil eyebrow data again. And it says, how would we construct a Venn diagram, or it should say construct a Venn diagram that displays the information in the two-way table. So we need to define our events down here. And I guess the way that I did it before, so typically you would see event A and event B. And let's go ahead and define, we need to write somewhere what those are. So let's say event A is I randomly draw a student out of these 200 and they can taco tongue. And event B is going to be, I randomly draw a student and they can evil eyebrow. Where I always like to start is the overlapping. So think about what that would mean. These would be students who can do both. Yes, yes. And so taco tongue, yes. Evil eyebrow, yes. 42 is where those two events overlap. So I always like to start by putting that in there. And if you want to label that for yourself, these students can taco tongue and evil eyebrow. So again, you can see visually now that there's that overlapping. So these 42 students belong to circle A and they also belong to circle B. So then what we're going to do is we are going to figure out how many students can taco tongue but cannot, so they're outside of the evil eyebrow circle. So taco tongue, yes, but evil eyebrow, no. Taco tongue, yes, evil eyebrow, no. And that's that 107 right there. And I'm sure some of you are way ahead of me here. Now we're going to figure out who said they can, yes, evil eyebrow, but no taco tongue. Yes, evil eyebrow, no taco tongue. And that's 20. And then lastly, so taking information from a two-way table is super duper easy. I want you to know that in this rectangle, you are going to put a number generally in the lower, one of the lower corners here, of the students who can do neither of these things. So no, no. And that is these 31 students right here. I want you to note to yourself that if you add all 4 of these numbers, you get 200, which is the total number of students involved in this survey. So all numbers add to 200. Make a little note. And if Venn diagrams have always been kind of tricky for you and you kind of want to label what everything is, pause this video and you can go ahead and kind of draw arrows to yourself and tell yourself what categories these are, like I have done with the arrows. A lot of you don't need that. All right, last page. So these are things that you may want to end up sketching on your formula sheet, especially these two right here, okay? So typically you won't see a Venn diagram with just one circle, but what this shaded region represents is anything that is not in event A. And so this goes back to that complement rule. This illustrates complements. Events that are complements to each other. It's really simple. If you're not in event A, then you're in not A. That A with a little c is called not A. So I want you to just write that AC is the complement of A and contains the outcomes that are not in A. And you won't really see a Venn diagram with just one single circle on a test or a quiz, so I'm not going to spend a whole lot of time on that one, but just know that the shaded region represents things that are outside of event A. It's pretty obvious. Now the next two are the important ones, okay? So you need to get really comfortable with this symbol right here, okay? That is the intersection symbol, okay? And that looks like a little lowercase n. That is intersection. On a Venn diagram, it's really easy to look at the shaded region. It's where the two circles intersect. It's the overlapping region. It's those 42 students that can do taco tongue and evil eyebrow. That's the intersection, okay? Now, intersection, I want you to make a note here. This is going to be hugely important. It's considered event A and B. So sometimes on your formula sheet, you won't see the symbol. Instead, you'll see, instead of A intersection symbol B, you'll see the words A and B. Those mean the same thing. They are interchangeable. Okay, you've got to understand that. And then just make a little note that the intersection symbol looks like an N. And the word and has an N in it. That's going to help you remember that this is and, A and B. People who are in A and B. Okay, moving on. A lot of you know what this symbol is. It's the union symbol. It looks like a U. So that's going to be helpful. Notice the shaded region is all of it, except for the rectangle part. It's anybody who is in A, or anybody who's in B, or anybody who's in both. It's everybody. It's the union. So I want you to write underneath there that union is interchangeable with A or B. Anything in event A, anything in event B, or anything in both. And make a note that the union symbol looks like a U. Once again, on your formula sheet, sometimes these are interchangeable. Sometimes you'll see the union symbol on, let's say, a test. Sometimes you'll see or. You need to know that they're the same, because if your test says or, and then you go to your formula sheet and all you can find is this, it's the same thing. So that addition rule that we covered a couple of pages ago can now be summed up with our new knowledge of symbols, where we had to subtract the overlapping, those 42 students that were in taco tongue and evil eyebrow. The students that were in A and B, the intersection, that's all this says. If you want to find A union B, the probability of A union B, then you add what's in circle A and what's in circle B, and you just subtract out the overlapping part. For mutually exclusive events, A and B, the two events have no outcomes in common, so the circles wouldn't overlap. So just as a note, I won't put this on a test or anything, but if you ever see a Venn diagram where the circles do not overlap, those are mutually exclusive. There is no overlapping region, because if you'll remember, by definition, mutually exclusive means these are events that cannot happen at the same time. There would not be a person that could do both things at the same time. Okay, lastly, example 4 is going to have you actually draw a Venn diagram. In a large apartment complex, 40% of the residents read USA Today, 25% read New York Times, and 5% read both. Suppose we randomly select a resident of the apartment and record which of the two papers the person reads. Part A says, make a Venn diagram to display the sample space. A is going to be reads USA Today, and B is going to be reads New York Times. And then we'll use our Venn diagram to answer part B. So in part A, draw a rectangle. And the first time you draw these, they're not going to be beautiful, and that's okay. Get your two circles in there, and they're going to overlap. Because these are not mutually exclusive events. Somebody can read both newspapers. Go ahead and label with A and B, and we don't have to write the definitions because it tells us right up here in the problem what A and B are, so we don't have to rewrite that. Again, I like to always start in the intersection part, the overlapping region, and if you read up there, it says that 5% of the people read both. Typically, what you'll do is you'll take your percentages and you'll switch them to decimals. It doesn't say to do that. But I don't want to put 5 in there because I don't want you to think that maybe 5 people read it. It's 5%, so 0.05. Okay, well, 40% of residents read USA Today. That doesn't mean we're going to put 0.4 over here. 40% are in Circle A in its entirety. So what I have to do to get this little region over here that's not overlapping, these are people that read USA Today only, is I have to take that 40% and subtract out the 5% that's already in Circle A. So this would actually be 35%. Make a note to yourself how we got that is we did 40% minus 5%. We're going to do the same thing for the New York Times readers. Up in the paragraph it says 25% read the New York Times. Well, we've already got 5% in Circle B, so we're going to subtract that out from 25% and get 20%. So make a note to yourself that we did 25% minus 5% to get 20%. I want you to take a second then and see if you can figure out what percentage reads neither of these papers. Think about what all of these would have to add up to if we're talking about percentages. All the numbers need to add up to one whole, or 100%. So if you'll take one whole and subtract out 0.35 and 0.05 and 0.2, you'll find that 40%, or 0.4, read neither paper. So if it says to construct a Venn diagram, you're not really done until you've actually included this number that's in either set. So let's do part B. Find the probability that if we randomly select a person, they read exactly one of the two papers. So they either read USA Today or they read the New York Times, but they don't read both because it says they read exactly one. It's really easy. You're just going to add together the people who read only the USA Today and only the New York Times. So 0.35 plus 0.2 gives us the percentage of people, which would be 55% or 0.55, that read exactly one of the papers, but not both. And that's it. You'll have some more practice with Venn diagrams on your homework.